All right. When I was solving each of these equations, or each of these systems, I started off by saying we take the left-hand side of the equation, we add it to the left-hand side. We take the right-hand side, and we add it to the right-hand side. This means that if both of these are in standard form, so remember standard form is where we have a times x plus b times y equals 13, or basically all the variables are on one side in alphabetical order. Then when I go to add these things together, it's really straightforward. In this example, you'll notice that if I was to take the left-hand side of the equation and add it over here and take the right-hand side of the equation and add it over here, things just kind of don't line up very well. I would like my x's to line up with my x's, my y's to line up with my y's, which means I'm going to start by putting this into standard form. Now, you could actually, theoretically, put both of them into slope-intercept form, I suppose. But if they're both in slope-intercept form, I'd probably rather use the substitution method. In any case, let's see. Putting this first equation into standard form, I'll add 2x to both sides. I get 2x plus 3y equals 3. The second equation is already in standard form, so I get 3x plus 5y equals 7. Okay, so they're both in standard form. My next hurdle is to make it so that my coefficients on one of these variables is the same, but, well, opposites actually. So if I could make this positive 2 and make this a negative 2, that would work. But if I was to make this into a negative 2, I'd have to be introducing weird fractions here, because I don't know any way to multiply through this by some number to make that into a 2, or at least not by an integer. I would have to multiply it through by 2/3, I guess, but 2/3 would make those fractions. Well, I kind of want to avoid that. Instead, what I'm going to look at is I'm going to look at the least common multiple of these two numbers. LCM of 2 and 3 is 6. So the least common multiple of 2 and 3 is 6. The reason I'm looking at the least common multiple is because if I multiply through this equation by 3 and this equation by 2, I can make both of those into 6s. Now, I'd actually want one of those to be negative, so I'd probably change one of these to a negative. But in doing that, I could make my coefficients match and be opposite. There's nothing special about necessarily going with the coefficients on the x's. I could look at the least common multiple of the coefficients on the y's. So 3 and 5 is 15. If you're trying to figure out which path is going to be the easiest for you, you might do both of these and say, okay, well, the least common multiple here is 15, the least common multiple 6 and there is 6. 6 is smaller, so maybe I'll go with that one. There's no particular reason to go one way or the other, but I am going to go with the smaller number here. So I'm going to multiply the first equation by, I want this 2 to become a 6. So I'm going to multiply through the first equation by 3. I'm also, at the same time, going to multiply through the second equation by, let's say I want this 3 to become a 6. Well, actually I want it to be a negative 6. So I'm going to multiply through the second equation by negative 2. So this changes this system of equations to 6x, because I'm multiplying through the first equation by 3. 3 times 2 is 6x. So, 3 times 3y is 9y. And 3 times 3 is 9. Multiplying through the second equation by negative 2. Negative 2 times 3 is negative 6x. Negative 2 times 5y is negative 10y. And negative 2 times 7 is negative 14. So now that I've made these coefficients match up, when I add these two equations vertically, I end up getting a negative 1y equals negative 5. And, well, getting rid of that negative 1, I get y equals 5. So I have the y-coordinate of my solution. I'll now figure out what my x-coordinate of the solution is. I don't see a particularly good reason to go with either of these. I'll plug it into the second, though. Just because it's in standard form. I don't know. I don't have a good reason, like I said. Let's see. Plugging in y equals 5, so I get 3x plus 5 times 5 equals 7. That's 3x plus 25 equals 7. I subtract 25 from both sides. I get 3x equals negative 18. Divide both sides by 3. I get x equals negative 6. So overall, I get the point negative 6 comma 5. And again, I'm going to check my work here. For checking the original equation, I have variables on both sides of the equation, so I'm actually going to evaluate this twice. First off, the left-hand side, that's 3y, that's 3 times 5, which is 15. I can move this where you can see it. So 3 times y is 15. I expect the right-hand side to also evaluate out to 15 now. So negative 2 times negative 6 plus 3 gives me 15. So this point satisfies the first equation. Plugging it into the second one, 3 times my value of x plus 5 times my value of y, it's 5. I expect this to come out as 7, and it does. So I'm confident that I have the solution there.